Okay, try this other one that I'm sending. You say the same thing. Saying the same thing. 60 cents, same thing. Mm, do you go to type Amazing Maths on YouTube? On that YouTube, type Amazing Maths. The logo for the website and the YouTube channel is, you'll see a notebook with a pencil. Just type it either on YouTube or any. You can see. Is there any videos? Are you able to locate the channel? Once you do, subscribe to that. It will just do automatically if you click on that link. So are you seeing me on the right? I guess that fixed it. Can you send me the link on WhatsApp? The link But I'm using mouse. Let me see what it brings out. I think I'm sending you the my broadcast channel. That's why. Okay. Yeah. Give me that. Sure. Actually, I think we can start. Let's see. No, you can still see the. I still seeing the. Okay, so let's move on. Can you see the next question? Show that the line y equals mx plus 4 we thought shall intersect the curve y equals to x squared plus 3x plus n. The network. Don't worry, it's going to get okay. Okay, so the first thing we're going to do is, yesterday we talked about equation of a straight line, right? So every straight line is given by y is equals to mx plus. So let me put that in capital letter. Small letter also okay. Y is equals to mx plus c. The general is the equation. I'm typing of a straight line. Of a straight line in gradients intercept form. Okay. Where m is the gradient of slope and c is the what? I remember what c is again. Intercept on the what? Y axis. So for this problem, y is equals to mx plus 4, meaning that 4 is the intercept, isn't it? M is a variable, so we don't know what the slope is. Okay, so m is not known, so we need to find the value of m. What are other informations that we're giving? So that straight line will touch or intersect the curve. So the curve is actually quadratic. I hope you know that. So the curve is a quadratic graph. Am I correct? And it is given by y is equals to x squared. That's how I'm going to write x squared plus 3x plus m. So what happens when they intersect? Can you tell us, discuss about that? So don't worry, we have a lot of tools and software to make the class very lively and interesting. So what do they mean by when they intersect? Let's try and use GeoGebra to understand what is going on. So if y equals to mx plus 4, so I'm going to my GeoGebra. Now I'll pick on my it's loading. Okay, so that's the graph. So y is equals to mx, right? But m is actually not known. So if you do that, you won't get any reasonable stuff. Let me just show you. So what do you see? You see that there's an adjustment, isn't it? So it means m is now a variable. What are your observations? The intercept on the y-axis. So can you tell me from the graph? Look at the graph. The green line. It's cut where? 4, right? You see it now. by definition, we said generally every straight line is given by y equals mc. See, I'm teaching you theory and I'm doing practical so that the math will become tangible. Mathematics is a very interesting subject. It's just the way it is being taught in Africa. That's why students don't have interest. But I want to convince you that maths can be the best subject you learn, that it will just be so tangible to you, like you are touching things. Okay? So now the straight line equation is given by mx plus c. M is the coefficient of x, c is the constant. So if you compare it with this equation they gave us, m is not given because m could have been 2 or 3 or 4. That's why you see that in the GeoGebra it was a variable stuff, something that you can adjust. Okay, so let's even leave that because it's actually m we are looking for. Then c is given to us as what? 4. If you compare the two equations. And what does that c means? Intercept on the y-axis. It means that where the line cuts the y-axis, which is the reason why you see that that's the green line cuts the y-axis vertical as it's at 4 there. Do you understand? So you can see that if I adjust this thing, the intercept doesn't change, isn't it? It's just the slope that is changing. So now I've gotten the slope. Next, we need to plot the equation of the curve, which is now a quadratic graph. So let's go and plot that. So I'm going to type in y equals to x squared, please call it for me, plus x squared plus what again? Plus 3x, right? So x squared plus 3x plus 3x. So it's changing it to g for me because it's a new function, done function, plus n. Now it's not giving me plus m. So can you tell me why? I want to see. Okay, it has given me. So what do you see? Here, you know that depending on the value of my m is also changing, right? Because I set my m to be what? 1 point. No, actually my m was not 1.7, right? I think my m was just any, I just pick any. So let's do it again. Let's see what's going on. So I delete this. Let me just pick. You know, m is variable now. It's actually m we are looking for. We don't know what m is. We'll do it experimentally, but we'll also do it theoretically. So let me just use any stuff like this. Okay. So again, we have y is equals to x squared, right? Plus what? Sorry. S squared plus, so s squared plus 4x, right? No, 3x, not 4x. From the question, plus 3x, isn't it? You actually see that a graph is showing you, isn't it? And if you look at the graph, you discover that it has an intercept, isn't it? But the only thing is that where it intersects, sorry, let me move it up. There are two solutions. Do you see that? So here is one solution. You can always use your tools to find the actual value there. Here is another solution. But the quadratic equation is not complete because we have a constant. So let me add the plus m. So since the m in the first graph, the straight line graph, is the same. So automatically what will GeoGebra do? It will solve for that. Or let's just see what we do. Let me not see it. So plus m again. Do you see that now? Initially this m was 0.6, am I correct? So now when we enter, okay, so what's actually doing is that he's using the m there and putting it directly. So now I think what we should do is change the m to another variable. so that it will not be bringing that n into that one. Do you understand? So instead of saying give me another letter, let's say n, right? So I'm using n now. My m here is 0.6. I actually want it to give me another slider so that we can now compare the two of them together. Okay. Let me see. So let's see the trick that we can use for this. Just take n to be, I want to make n to be a variable stuff. Let's just say 0.6. Okay, so what we need there is, I think, a slider. So I need a slider for this. Just try and get a slider. Yeah, create a slider. This is what I'm trying to do. So I've created a slider for n. So now if I adjust it, you get it now, n is changing. So here now, the value of my n will change depending on my slider. Do you get it now? I think you should, you see it's also affecting the graph. This is very interesting. Depending on the slider I pick, isn't it? Which is the variable that is changing. But we are using n and m as different, even though we know they are the same. Because we want to avoid, we don't want it to be kind of picking the value there and putting it back. So now what we are going to do next is to equate the two functions. So the first function is f of y, am I correct? Is equals to, let's see, the other one is g of y. So you can see it's solving something there. So minus s squared minus 3s plus y equals to 0.9. So what's the solution there? Okay. The straight line. Unfortunately, I can't find the straight line again. So let me just remove this. Let me delete this out of this. Okay, so let's use the straight line. Y is equals to mx plus 4. So is the value of m is using there 0.6 plus 4. Y g of y is s squared plus 3s plus 0.9. The value of the n there. Okay. So the question, what the question is actually saying, let's go back to the question, is that when they intersect, obviously from this graph now, they intersect at this point and this point. You get it? But the value of n and m has to be the same. So let's say m equals to n. Let's check and see. It is bringing 0.9 out. So what it's just doing is just picking one of them, initializing. Okay. So but we'll get the concept anyway. So let's go to the theoretical part. Sorry. Y is equals to We have deleted some stuff. Is equals to, let's say, 0.6. Create a slider. Then y equals to x plus 4. Anyway, this is what we have. So we know that there will be two solutions. Let's go to the theoretical part. So how do we solve this? To solve this, we simply equate the two equations, because where they meet means their corresponding value of x and y has to be the same at that coordinate. So for intersection to occur, we have to equate the two graphs. So that means mx plus 4 must be equals to what? X squared plus 3x plus m. So we have to rearrange the equation. So rearranging the equation, we have, so all you just need to do is to take the ms plus 4 to the other side of the graph and then simplify. So when we do that, we have x squared plus 3x plus m minus mx minus 4 is equals to 0. Alright, so we can now factor the common terms in this equation. So since we want to make it to look like a quadratic equation, we bring this minus mx to be collected with 3 plus 3x, so which becomes x squared plus 3x minus mx. Okay, since both of them are xx, plus m minus 4. Because at the end of the day, those two is going to be a constant, isn't it? So when we factorize x squared plus, we can bring out the common term, which is 3. Sorry, x rather. X is common, right? 3 minus m plus, put the other one in bracket if you like, m minus 4 is equals to what? 0. So we can use almighty formula. Recall that general quadratic equation given by ax squared plus bx plus. So let's use that formula, see if we can get a solution. Recall that a general quadratic graph is given by y is equals to ax squared plus bx plus c. Okay, and its solution is given by so I hope I'll be able to. Solution is given by, so you have x is equals to I think a fraction. Let me see if I have some mathematical stuff here. Let me check insert. I don't think I have draw. Equation insert symbol and all that. This thing is almost word, but it's not. It doesn't have all the function of word. If not, I should be able to have those functions there. So I just make use of what I have. So I'll have minus b plus or minus plus or minus square root of b square minus 4ac. Hope you remember this formula. Everything divided by 2a. So that's the almighty formula. Okay. The notepad that means it doesn't have those equations. If not, I'll have been able to show it properly. So where a is the quotient of x squared, b is the quotient of x, and c is a constant. So let's compare now. Comparing with the above. Comparing with the above. So we have that a is 1, right? Because there's nothing standing beside x squared there. Comparing with this one, a. Okay, good. So a is 1 because x squared doesn't have any coefficient. B is, what do you think the value of B is? That's 3 minus m, coefficient of x. And C is the remaining constant term, m minus 4. So we'll use it into the equation. So which means that, so I'll just copy this. What's going on with this? I'll just copy this. Copy. Paste it here. So my B is 3 minus m. So 3 minus m minus into bracket 3 minus m will become m minus 3. So this will be m minus 3 minus 3 plus or minus square root of Now what is inside the bracket is going to become 3 minus m all square minus 4 times 1 times m minus 4. So I have to do let's do the let's see what the whole of this will be. So it's a bit of complicated algebra, but no problem. So b square is going to be 3 minus, I'm bringing that one out so that we can deal with it separately. All square, you see it now? Minus 4 times 1 times c, where c is m minus 4. So when you open your bracket, 3 minus m all square will become 9 minus 3 times n. 3 times minus m will be minus 3m. Minus m times 3 again will be minus 3. So minus 3m plus minus 3m, that will be minus 6m. Then minus m times minus m will become plus m square. Plus m square minus, so you can open the bracket, 4 times 1 is 4. So let's just say this is 4. 4 times m is 4m. 4 times 4 Minus 4 times 4, that will be plus 16. Okay. Let's pray that this thing is going to be factorizable. Over 2, this 2a will be 2 times 1 because a is 1, so that will be 2. Let's pray it's going to be factorizable. At the end of the day, we'll equate everything to 0. So let's just see what we can do. It's really interesting. So now, this is going to become m squared. Hope you are seeing that too. I'm rearranging the stuff now. M squared minus 4m minus 6m become minus 10m. You see that? What else again? 9 plus 16 will become what? Plus 25, right? Which is equals to m minus 5 whole square. If you do your factorization using your difference of 2 square. So I'll use another this thing to teach you how to factorize. So here we have m squared minus 10m plus 25. Suppose you want to factorize it, how are you going to do that? So let's use our manipulatives. Use algebraic time. We are seeing the algebraic time there. So we use what we call completing the square method. So here we are going to be using this big stuff here. Of course, it's not m squared we're going to be using. Let me write it out. What we're using is x squared. Let me use this one. So our equation is what? X squared. I'm taking x to be m minus 10x abi. Don't forget your x is now m because of what we have here. I can actually see what you need to do to complete this square. So I will teach you completing the square using this stuff. But it's more intuitive. I know that I have to add 25 to it, but let's put 25 there. But we'll first pretend that we don't know what we need to add to make it. We don't know whether it's perfect or not. So you pick your x squared, bring it here. You see that? 25. I need like sorry, minus negative 10x. I can pick this minus x in 10 places. You see what I'm doing? The idea of quadratic is we make a square so that this side and this side has to be the same. So after using this thing to teach you, you discover that you just have a concrete knowledge of how to do factorization or those algebraic stuff. So I will make this one into 10 places because this is 10x. So usually you just do copy, I think 9 times. Copy, that's 2 now. 3, 4, 5, 6, 7, 8, 9, 10. Mass is 4 actually. So now I now have to now arrange it. So if I arrange it, how am I going to have it? I can have it here. So it's now for you to now start building your ties. See what I'm doing? I'm even doing 3 like this. Let's hope this will work. For me to have a perfect square, my length and my breadth has to be the same. So the whole shape, length, and this x square means here is x, here is x. Are you with me? And that's what it means. I can even raise it up a bit. Let me even bring this one here. So here is x. All this place is negative x, like x is not this thing there. So I'm coming, looking at what to do. Okay. Let me bring this one here first. For now, let's just leave this arrangement like this. So let's pick 25. We'll pick 1 into 25 places, which is this yellow stuff. So I'll just copy 25 times, 24 times. 1, 2, 3, 4. It's 5 now. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, get it? So let's see what we're going to do. So we have to fill up the space. To fill up the space, let's see what we're going to do. So I have x. The idea is that x times x gives us x squared. This one is 1. I hope you know that. This red one is 1 times x. So I've not formed my square. Let me bring 1 here. Because my idea is I want to make everything to become a square. All this side of the red is 1, 1. I hope you know. But for the blue square, x, x. So you are like putting them in form of areas. Let me put 1 here. So that I'll have where to put my all the 25. Let me bring this one here. Are you seeing what I'm doing? Because if I don't do that, those 25 are too many. I won't be able to form my square. So if I cannot form my square, then I know that the square is not complete. So that means I will now ask myself, by how much should I need to put to make it to be complete? That's the idea of perfect square. You can see the math is actually becoming intuitive for you to understand. I want to zoom this thing so that this thing here. Do you understand? So here is x, here is also x. Get it now? This, okay, hold on. This thing is x. So let me do it this way. I want to do something. I want to rotate. So here like this is x. This is 1, but it's 1 times x. No, negative 1 times x. You get it? It's negative 1 times x. But this one is positive x times positive x. This red one is negative 1 times x. You can remove this thing. So this is actually x minus 1 minus 1 minus 1 minus 1 minus 1. That's x minus 5. So I want to do something like that here. So I think I will have to rotate this guy. This is what I'm doing. This is what I'm doing. I'll rotate again. You see? So I have x here. You know this place is -1, -1. So just be looking at it, you see where the idea is coming. Because that space is too much. Oh. If I do that with that space, those 25 stuff will not be able to enter inside. It won't be able to enter. So I have to actually creatively think of how I'm going to tie the algebra. So can I fill in the remaining of this here? Let's see. You can see that this one is 1, 1 now. It's entering into this thing. Do you see that? Do you see that? Do you see that? I've put 5 there. 5 times 1, 2. So it should enter, right? Because I have 25 of them. Putting this other one there. Next, I'll pick another group, right? 25. Okay, I'll pick another group again. Because the idea of this factorization is to make either a rectangle or a square. If it's a square, that means it's a perfect square. If you cannot get area of a square is L square now, so that's s minus 5 all square, isn't it? So if you expand it, you get x squared minus 10x plus 35. All right, very intuitive. So let's go back to so I can now put it here as x negative 5 all square. I'll give you some other lessons whereby you have a lot of perfect square and incomplete square, and I think I'll take some examples whereby you use the algebraic tie, and once you learn the algebraic ties, all this algebra stuff will just be so easy for you to do. You yourself can testify the way the thing is coming out. So you are not playing with the mathematics like you are playing with how do I put it, geometric shapes. So now your x will now be, so we can take the square root, right? So the square root of everything inside here, am I correct? I actually have a graphic pen, but I prefer this one because of my screen. So usually I use my graphic pen to teach. So if you take the square root of that, what will be left? S minus 5, isn't it? So going back to our equation, this are, sorry, what time? Yeah, we should be stopping because we started late, so we should stop by. So if we take this example, we'll be done because we are supposed to start by I think around 9. So we didn't start early. But with this example we have done, I think we have covered so many things. So now I will just copy this and then here. Okay, so it now become equals to, in curly bracket, n minus 3 plus or minus, isn't it? Plus, I don't have all the function, that's why I'm right putting it this way, plus slash minus square root of whatever there is x minus 5, but it's not x, it's n. So let me quickly correct myself, right? So I'll put that in bracket. Always remember your Goldman's rule so you don't go and make a mistake. All in curly brackets divided by 2. So there will be two cases, right? Case 1, when it's positive, when it is positive. You understand what I mean by that? Because quadratic equation is always having two solutions. So when it's positive, you have n minus 3 plus, isn't it? into bracket n minus 5, right? Everything divided by 2, which is going to become n minus 3. You can see the way I'm carefully obeying the rule of BODMAS. Plus times m will be plus m, right? Plus m. Plus times minus will be minus. Minus 5 divided by 2. Remember, everything is equals to 0. So let's not forget. So equals to 0. I'm bringing it here so that you don't forget. Equals to 0. Equals to 0. So this one too is also what? Equals to 0. So which means become m plus m is 2m. So which becomes 2m minus 3 minus 5. That's minus 8. Isn't it? Divided by 2 equals to 0. So when you divide it by 2, you can factor out, isn't it? So when you factor the numerator, you have 2 into, what's the common factor? This common factor, m minus 4, right? Are you with me? Or the numerator divided by 2 equals to what? 0. So which becomes 2 will cancel 2. That will be m minus 4 equals to 0, right? Which means that m has to be what? 4. So we've gotten the first solution. Case 2 is when it is what? Minus. But those are the two solutions for quadratic. So I'll just copy everything here and then we'll just do a little bit of editing. So where I see plus, I'll put minus, right? So m minus 3 minus m, isn't it? Minus times minus will be plus, so this one will be plus 5. So it becomes m minus m will be 0, so m will be out, right? So this one doesn't have any solution because you have, since m is out, it's m you are looking for now. So minus 3 plus 5, that will give you 2, right? 2 divided by 2, 1. 1 is equal to 0. Impossible. So this one doesn't have common. Hope there's no mistake in this stuff. That one doesn't give any solution. Because just be m minus 3 minus, which gives no solution. Which gives, don't worry, we'll use our practical stuff experiment to check it. Which gives no what? Solution, right? So which means m has to be what? Which means the value of m is what? M is 4, right? So let's go back to our GeoGebra. Now we can put in a value of m. We are no longer using slider, or we can just use this, adjust the slider to the value that we have solved for. So we can just delete this, isn't it? We don't need slider again, right? So the first, y is equals to, m is 4, right? 4x plus 4, right? Then the second one is y is equals to x squared plus 3x, right? Plus 4. Can you see it's just one solution? So you can see that both experiment and theory doesn't lie. Because looking at the graph, you will have thought maybe, I wanted to think maybe, are you sure it's one solution? Let's check. There's a little bit of issue here. So maybe I'll give you as assignment to go and find out the other this thing. Because see here now, it meets it here, right? 4. Okay, this one is at 0. Wait, let's see. Okay, those are the two value of x. You know, we solve for m, right? M is just one value, which is the reason why, okay, that's the reason why it's cutting, you know, where the straight line cuts the axis is also where the quadratic also cuts the distance. So both of them meet at the same point. So it's correct. The only thing is that the value for where they intersect, this here, they intersect here, y is 4, and then they intersect here. Let me use my intersect. Okay, that's intersect. Y is 8, right? So let's go back to our equation. So what do you think we need to, so let's check our equation again. Look at it very well, because we want to actually get the two cases. So let's look at it again. But we have to actually get it to let's see. Show that the line, okay, show that, what did they actually ask us to do? Show that the line y equals to mx plus 4 will touch or intersect the curve y equals to x squared plus 3x plus m for all values of m. Okay, so the question is saying that, so what the question is actually saying is that any value you pick is always intersects. That's what it's saying. Like, so let's say, let's go to the GeoGebra. Let's say we pick 1, changing to 1. Does it meet? It does, right? So any value you pick, it will always work. That's what the question is saying. So they did not actually say we should find the value of m. So I think we misinterpreted it to mean finding the value of m. So show that the line y equals to mx plus 4 will touch and intersect the curve is for all values of m. So we have to show that any, irrespective of the values of m you pick, it always works. So let's go through it one more time. So we started with the equation of the straight line. We got the distance y mx plus 4. Then the curve is a quadratic, which is given by x squared. So here I need to go to the board and check some things. Okay, so equation, first one is y equals to mx plus 4, am I correct? Then the second one is x squared plus 3x plus m. So once you do that, any respect of the value of m, it's always in it. So putting them, we have x squared plus 3x plus m also m plus. There's actually what we did here. Just for us to spot the linear. So bring up this one here. So x squared plus 3x minus ms plus m minus 4 equals to 0. Because we need to convert it to quadratic. So now, after writing down x plus
3 minus 3 plus x is common plus n minus 4. I think that's what we do. That's actually the same. So now using our formula method, s equals to minus b plus or minus square root of b squared minus 4ac over what 2a. That's when you're giving the quadratic y equals to ax squared plus bx plus c. So here our a is what 1 because coefficient of x plus 1. Our b is what 3 minus 10. Our constant c is what n minus 4. Okay. So that should be able to go inside the square root. So this square root of 4 is 3 minus 10 whole square. And 4 times 3 is 100 times n minus 4. So let's check. So which becomes 3 minus 7 becomes 9 minus 6n plus n. So how do you do that? Then open the bracket minus 4n plus 16. It's the same thing. So which becomes rearranging x squared, this plus this will be minus 10 plus 25. Which one will become the great guy? After it, isn't it? So the square root of this square minus 4 is the square root of n minus 5 also, which is n minus 5. So we are actually on the right track. So if we use it there, x will be minus, what is our b? 3 minus 10 plus or minus the result n minus 5 divided by 2 times 1, which is 2. So minus this one will be plus because this will be minus 3 minus x minus 7 plus n. So you can rewrite it as n minus 3. I will use that plus or minus n minus 5 over 2. Remember, everything has to be equal to 0. Don't forget. So the first case is 1. Is 1 it is plus. So that will be n minus 3 plus n minus 5 over 2 equals to 0. Which equals 2n minus 8 equals 0. Which equals n equals to 4. Gives 2. N minus 3 minus n minus 5 equals to 0 plus 2. Which equals n minus 3 minus n plus 8 equals to 0. So this actually won't give us any solution because we can't actually find the value. So we're actually on the right track. So minus plus 5. Minus 3 plus 5. That's 2. So what is 1? Not. That's the question. What do you get with 8? Yes, 2 n minus 8. So n plus n here is 2n. Minus 3 minus sorry, there's over 2 here. So when you cross multiply, so this one will lead to a contradiction, but one can be equal to 0. So this other case is not valid. The only case that is valid is n equals to 4. So from what is saying now, or from what we have done, for the two of them to be equal, n has to be 4. Because when we actually try it with other values, we can see that it actually intersects. So we look at how we're going to interpret the question. Because if you say two lines or the line and the component, it means their y axis has to be the same, or their x and y has to be the same. So that's what it means. So what I would have expected is that, okay, I think I get the idea now. So case two actually answers it. Case one shows us that it's going to work when n is equals to 4. Case two works for any value of n. Now, let me explain to you. You just need to know. For any value of n I pick here, they will always cancel out. But the problem is where I have one problem. Because if I think these two things are equal now, so that will be okay. What I'm saying is I think at least they will cancel out. Let's say what you now have here is minus 3, what you now have here is, let's say, 3 or so. So that 0 equals to 0. But this case is actually a contradiction because 1 cannot be equals to 0. So we cannot go with this case. So the only case we can go with is a case whereby n will cancel out, there will still not be contradiction. So if you have a situation whereby n cancels out, you still don't have a contradiction. Let's say that 0 equals to 0 or 1 equals to 1. Then you can say that irrespective of all value of n that you pick, it's always going to work. So we'll go home as assignment and see if basically solve the question because we show that there is a particular value of n that works. The only thing that we have not shown that for all values of n, because if for all values of n, anything you pick, and if you do the experiment, you see that any value of n you pick is always working out. So, let me end the batch.